Reality capture post-processing. Close holes tool. A very interesting editing tool is the gap closing tool. The tool is responsible for joining polygons between which there is a gap without information. Smoothing tool. The smoothing tool can be applied to the whole model or to selected sections. This tool removes or smooths the roughness of the model, transforming the models into smooth elements without relief if used excessively. It is possible to see how the roughness of the model decreases as the number of magnifications selected in the left panel is increased. This powerful tool should be used lightly as it can cause deformations and loss of important geometrical information from the original model. Simplify tool. We select elements that we want to keep without reducing polygons and select the invert option to select the rest of the points. The Simplify tool reduces the number of polygons in the mesh of the selected zones according to the desired values. This tool helps to reduce the weight of the final file. As no polygons have been removed from the signs, they will retain their original polygonal and texture information in the model. MeshLab post-processing. It is of great importance to provide the coordinate model both for your alignment as for keep true scale. As we can see, thanks to the coordinates of the drone, the church is aligned. However, the model of the arc structure is not aligned and will possibly have a greater scale divergence with reality. Polygon mesh and point cloud editors such as MeshLab can provide endless tools for mesh enhancement, point cloud, or even texturing. In this way, we can reduce the polygonal mesh into a larger number of polygons in a more orderly way. This results in what is known as a low poly model, a model with little geometry. Options that MeshLab allows is also the change of mesh from triangular polygons to square polygons in quads. These join more vertices and their faces usually have a larger area. High poly and low poly. This 3D model, BIMVET3, represents a high poly model, a model with a high polygon value. In this example, we can see how the number of polygons of a textured model is reduced. The visual imperfections are not noticeable until 577 of the original 4091 polygons are left. The reduction of polygons in the model makes the shape of the model gradually simplify until it is unrecognizable, generating a low poly model. Looking at the wireframe view of the polygons, it is possible to appreciate the gradual loss of information, sometimes duplicated and sometimes of importance to maintain the true shape and volume. Comparison with Cloud Compare. The loss of important information is not always noticeable, so software such as Cloud Compare helps us diagnose our model. we insert the two three-dimensional entities to be compared. In this case, a photogrammetric polygonal mesh and a rock model that simulates the alignment of the pillars. Select the Find Registration option on the top panel to align and overlap both models. Once the models are aligned, select the option Compute CLUD Mesh Distance to measure the distance between both models and visualize the divergences. We can activate various indicators that help us to understand the scalar field and the distribution of divergences of the compared models. It is also possible to extract individual information from concise points and areas of the model, such as negative points below the compared surface or positive points above the compared surface. CLUD Compare provides numerous quantitative data on compared 3D entities, point CLUDs, and three-dimensional meshes that can help you refine your work.